we need to get an overview. In this course, you're going to be going through all sorts of different variations of cloud. And so I want to have a grounding, a fundamental understanding for you so that even if you didn't listen to the rest of the course, you could look at this and say, okay, I get the basics of it. What happens a lot in courses like this is that we lose sight when we dig down into the deep details of something, we lose sight of the big picture. So the cloud overview is the big picture, and that way if you're missing anything, you say, well, okay, let me go back to basics. I can go here. You can get to this video and it should get you what you need. So we need to start with basic definitions of what the cloud is. Some really talented people have been talking about the cloud since 1961. I mean, John McCarthy from MIT said, you know what, someday this computing that we're doing is going to be a public utility. Fast forward to now, 2012, then it is in a lot of cases. Gordon Bell, you may not know him, but I know about him because he wrote a lot of underlying operating systems like Windows NT. Now we're all the way up to Windows 2012. And what he said is that computing power, computing classes, the cost of this is getting lower and lower and lower. So what we're going to do is we're going to combine this together. We're going to create programming platforms, networks, and interfaces, and we're going to bundle this all and sell it as a package. That programming platform hint from around the 80s foretold what was going on now, which is platform as a service. Now, fast forward to Google and Amazon. Google says, you know, early internet days, we knew the network was a cloud, so why not make the computer a cloud? Because the routers and switches have got operating systems on them. They just don't do anything except for pass the packets, right? Now, interestingly, when we look at Jeff Bezos from Amazon, I think that he made a great company to sell books, but underlying all of that, what he realized was that he needed all this horsepower and that he was connected to the internet, and now he said, okay, well, these abstractions that we're going to create, these infrastructures, these complexities of servers all need to be washed away so that you don't need to worry about what piece of hardware that is or what piece of hardware that is. So those are some people from the past and from the current that talk about cloud computing. I think the one we want to pay attention to here is Kevin and Jeff, to be honest with you. Okay, so where did the term come from? Where did cloud come from? Well, the first time that it ever came up was around the concept of networking and the abstraction of TCP/IP. Think about it. The original idea for communication over the internet was to route around failure. If we go all the way back to the early days of DARPA, and we look at what the US military was trying to do, they said, what happens if a bomb goes off in the center of the country? How will we communicate from East Coast to West Coast? Well, what we need to do is we need to abstract that so that the data can flow anywhere it wants to, and we don't care where it flows through. They were talking about a cloud at that point. The second time around we started seeing this is around data abstraction. So we went from layer 3 and 4, now we go all the way up to layer 7 if you're paying attention in the OSI model. Okay, we still need a definition of cloud. And so what I say is a cloud is a misty thing. So I want to demystify it. I want to make it simple so that if you had to talk to somebody else that doesn't understand the cloud, how could you explain them? Well, it's an abstraction of resources. You don't care what it looks like at the power company, how they actually generate the power. It's an abstraction. It says, okay, out comes the power. Just like with the water company, out comes the water. And it's done through layering. We can build one layer of abstraction on top of another, just like the OSI model. Finally, this really is nothing more than a contract. So what happens is some company, like Amazon or Google, has optimized all of their computing power, and they organize all of this stuff, and they rent it to you because they don't need these CPU cycles right now, so they can offer them to you. If they needed them, they'd take them away from you based on your contract. other times, what we do is we don't take just large organizations like Amazon and Google, but we look at organizations like telcos, and they have lots and lots of space. If you were to actually go into your local central office today, instead of having racks and racks and rows of computer equipment in those locations where they used to fill up the entire central office, they've shrunk all of this down. I went to Dallas about 4 years ago to see the central Verizon hub for all of their telco switching. I'm used to rows and rows and racks of telco equipment, and I said, well, how much of this is actually dedicated to telephony only? And they pointed to the one rack over there and the other rack over there, and they said, that's it. I said, didn't that used to fill this whole room? And they said, yes. So what are they going to do with that space? They're going to rent that extra space to you. So it could be the telco renting it to you, it could be the large corporation renting to you. Really what this boils down to is somebody's trying to put lipstick on a pig and sell it to you. Now hopefully your job, and that's what we're going to do here today, is we're going to demystify cloud and say, are you really offering me the service that I deserve? Is this really what we've contracted for? Don't let them sell you a pig. Get them to sell you something better. Okay, so now we need a working definition, something technical that we can walk away with. So I want to read this to you and take a look here on the screen. Cloud computing is a pay-per-use model for enabling available, convenient, on-demand network access to a shared pool of configurable computer resources, networks, servers, storage, applications, and services that can be rapidly provisioned and released with minimal management effort or service provider interaction. I would say that if you're going to take an exam, this would be that question. This would be that answer to most of those questions. It encapsulates everything that we're doing when it comes to cloud. We're going to rip this definition apart 3 or 4 times throughout this course. There are 3 key characteristics, 3 delivery models, and 4 deployment models. Also, if you're playing along at home and you're trying to get ready for your exam, you must know these 3, 4, 5, and we'll get to each one of those. Okay, so let's look at the cloud characteristics. High-level definition of this. We can dig deeper later. On-demand self-service. Well, you know video on demand. You know I want to watch this fight. You know pay-per-view, those kinds of things. You know I want to look at this video. I want to download it from some location. Do you have to call somebody up and say, yeah, I'd like to discuss with you, will you rent this? No, you just click a button, on demand, boom, and it's there for you. Self-service, boom, there's a website. You don't talk to anybody anymore. There's no calling somebody else. There's no going to the video store anymore. Well, hopefully you still go to the video store. Ubiquitous network access everywhere. If you've got an IP address, TCP version 4 or 6, then you've got connectivity to it. It has to be there through the network. Location-independent resource pooling. You have no idea where this stuff sits. There could be servers over there, there could be storage over there, half of the servers could be here, half of the servers could be there. You don't care. It's location independent. Now, that may be very different when we talk about your regulatory compliance. Rapid elasticity. Fast, that's rapid. Elasticity, like a rubber band. For what? For the service itself. Well, what does that mean? That means that if I want 5,000 computers and I'm using one, I can have 5,000 computers. If I want 10 gigs of RAM and I've only got 2 a portion, I get 10 gigs of RAM, just like that. Oh, I don't need that anymore because my workload's gone away, because my season is past, because my customers really aren't buying right now. Shrinks back down again. That rapid elasticity is the key fundamental business driver in all of this. If you needed 10,000 computers to do a job to sell for 1 month out of the year, and you were to buy that infrastructure, that would be expensive. What you could do is you could say, I'll rent it from somebody else. Do they want a long-term lease or a short-term lease? Well, rapid elasticity allows you to do a very short-term lease. Pay per use. I want it today, I don't want it tomorrow, I turn it on now, I wait 5 minutes, I turn it off, I turn it on 15 minutes later, and I let it run for a year. pay per use, all built into it. Now we need to talk about the cloud deployment models. Public cloud is what most of us know today. But in the enterprise, we could have a private cloud where you own it completely internally. Usually we talk about this in terms of virtualization. So we've got private and public. Those are pretty easy to understand. What about this community? In the community, we've got a shared common goal of some sort of requirement that we all get together around. We don't allow it just one organization to work with it or every organization to work with it. It's just our subset. Normally what we talk about is private and public clouds. We don't talk about community, and we certainly don't talk about hybrid. And a hybrid is some mix of the other two. More details on that later. You can also have internal and external on all four of these. You can have an external private cloud. You go, well, Dean, how would that work? And what I say to you is that you could get somebody else to build a data center for you because they are data center building experts, and they could lease it to you. It's just like when you lease a building. People who build out those buildings are experts in that, and they lease it to you, and it's not really yours, but you're having it for exclusive use. Last thing we want to talk about here before we break is service level agreements. This is all about contracts. If you were to get somebody to do anything, if you were to rent a building, if you were to get water, if you were to get electricity, you would have to have a contract. That contract should, in most computing, should talk about performance metrics, how well they do what they do. What's going to happen when there is a problem? How will they manage it? And they'll explain that to you. They'll explain the security and what you can expect and what you cannot expect. And in a lot of cases, when it comes to public cloud, security is on you, depending on the model that you're using. Penalties for non-performance. Generally, it's just a refund because you didn't get it. You can't say to the power company, I couldn't get into my freezer, so I'm going to charge you because you've got to pay because my meat spoiled. They go, well, you just didn't have power that day. That penalty for non-performance is usually recouping their service and not protecting you against failure or loss within your business. It's limited there. And finally, performance defined. What is the uptime? What is the scaling for that? That's all inside your service level agreement or your service contract, depending on who you're talking to. We're going to dig deeper into contracts later on.